Hey everybody, Dr. A here, and in this video we're going to be providing another example of LRFD load combinations. So let's go ahead and get started. In the given information, we're being asked to determine the controlling LRFD load combination and the design compressive force for the column. So here we have this vertical member subjected to compressive forces, which are typically called columns. Now, this particular column is pin connected at its ends. However, that's not super relevant for this problem. That's just for graphical purposes. Now, this column is subjected to service loads of a 55 kip dead load, a 35 kip live load, and a 15 kip snow load, okay? And we show the compressive loads kind of lumped together at the top and the bottom for the purposes of showing equilibrium, okay? So as we jump into the solution, the first thing I'm going to do is I'm going to say, let's reference chapter 2 of ASCE 7, and specifically I'm looking at 7-22. Okay, so chapter 2 of ASCE 7 lists out applicable load combinations, and I'm looking at ASCE 722. If you're looking at an older version of ASCE 7, the load combinations might be a little bit different. So just make sure we're looking at the right reference and we're following along. So as we dig into this is a pretty straightforward problem. What we want to do is look at what LRFD load combinations are going to be the most applicable here. So I'm going to make a note here. I'm going to say applicable LRFD load combos. And of course, the applicable load combos are going to be the ones that include dead load, live load, and snow load, okay? And so if we list those out referencing ASCE 7, the first one that is going to be applicable is 1.4 times the dead load, okay? The second one that's going to be applicable is going to be 1.2 times the dead load plus 1.6 times the live load, and then plus this larger term with or statements in there. And so that'll be plus 0.5 roof live load or 0.3 snow load or 0.5 times the rain load, okay? Now, the question in this problem specifically has dead, live, and snow load. Now, a roof live load is considered different than a regular live load, okay? So what we can do is we can say, all right, I don't have a roof live load in this problem, so that's not going to govern. And I don't have a rain load in this problem, capital R, so that's not going to govern. So this is going to quickly reduce down to 1.2 dead load plus 1.6 live load, and then plus 0.3 snow load for this problem, okay? Now, the third load combo we can list out that could be applicable to this particular problem is load combo 3. That's going to be 1.2 times the dead load, and then plus, again, we have kind of a longer term or statement, 1.6 roof live load LR or snow load or 1.6 times the rain load, all right? And then we have a third term plus live load or 0.5 wind load. W is wind load. Now, again, you want to kind of cancel out what we don't have. So we don't have a roof live load, we don't have a rain load, and we don't have a wind load, okay? So what does load combo 3 from ASCE 7 reduce down to? It goes down to 1.2 dead plus S plus L, okay? So that reduces pretty quickly. Now, looking at these three load combinations that are applicable to us, can we further reduce down any of these just off the top of our head? Probably not, because you know, you could argue, well, you know, which one's going to govern, 2 or 3? Well, they both have a 1.2 dead load term. Load combo 2 has 1.6 live, which that is going to be bigger than 1.0 live. But load combo 2 also has 0.3 S, which is going to be smaller than 1.0 S. So at this stage right here, I would not try to wipe out anything else. Okay, I would just start at this stage evaluating my actual numerical values. So I'm going to draw a line here, and just to kind of help us stay organized. And I'm going to substitute my values in, okay? So for load combo 1, I'm going to have P sub U, okay? So that's the ultimate force. I'm using the notation for, force now. P sub U equals 1.4 P dead, all right? And if I punch this through, I'll say 1.4 times that 55 kips. And when I get that evaluated, I get 77 kips. All right, load combination 2, P sub U, again using the force notation now, 1.2 P dead plus 1.6 P live plus 0.3 P snow. So if I substitute these values in, of course I get 1.2 times 55 kips plus 1.6 times 35 kips, and then plus 0.3 times 15 kips. And we can punch that in our calculators. Let me double check my math here. So 1.2 times 55 plus 1.6 times 35 plus 0.3 times 15. And so here I get 126.5 kips. And then finally, we're going to evaluate load combo 3. So we'll have PU equals 1.2 P dead plus P snow plus P live. And so we get 1.2 times 55 kips. P snow is 15 kips. And then P live is plus 35 kips. And we evaluate this, we get 116 kips. Okay, so finally, what's the conclusion here? Well, the conclusion is load combination 2 governs. Okay, so I'm going to say therefore load combo 2 governs, and the design column force is what? It's going to be PU equals the 126.5 kips. So that's the solution. And what that means is if we were to design this column, we're going to design it for 126.5 kips, which was developed and came out of load combination 2. Okay, so that concludes this example video. If you found this helpful, please hit like and subscribe and be on the lookout for other content like this. Thanks for watching.